All right, hello, Math fans. All right, so this is day 8, and this is solving radical equations. All right, so solving radical equations. All right, so this is the deal here. Let's just start out with a real basic problem. If I said the square root of x equals 3. Remember, I've always told you guys you do the opposite of what you have. In other words, if I have x plus 3 equals 10 from back in the day, I do the opposite of that. So instead of adding 3, I subtract 3 from both sides. So you get x equals 7. Same thing with multiplication. 2x equals 20 divided by 2, x equals 10, right? I do the opposite. So this is multiplication, I do division. This is addition, I do subtraction. So what is the opposite of taking the square root of a number? The opposite of taking the square root of a number is squaring a number. So remember, I'm trying to pull a lot of stuff together. If I said the square root of 5 squared, isn't that just 5? Doesn't the squaring a square root just remove the square root? So watch this. If I square both sides, and again, you have to do both sides because that's how an equation works. You've got to balance it. If I square both sides, the square root goes away, I just have x, and my answer is 9. That's the answer. Okay, so think about it. This is the original problem. Right, the square root of x equals 3. So if I put a 9 in there, isn't the square root of 9 3? So that's why x equals 9. Okay, so this is the main thing here, is you square both sides. Okay, and that eliminates the radical. Okay, does that make sense? I hope so. So the square root of x equals 9. Okay, sometimes people want to take the square root, but I mean, think about it. You've got to get rid of the square root, so you square both sides. So x equals 81. Okay? Pretty mellow, pretty mellow. Okay, so let's go something that's got a little bit more depth here. If I said the square root of x plus 4 equals 10. Okay, this is the main rule here, guys. The rule is isolate the radical. Okay, so it's really isolate the radical with the variable. So it's like basically you're solving for radical x. So I'm going to subtract 4 from both sides. So you get the square root of x is equal to 6. And then what do you do to both sides? You square both sides. So x equals 36. Okay, pretty mellow. Let's try another one over here. How about 2 root x minus 3 is equal to 1. Well, again, I isolate that square root of x by basically treating that just like an x, and I have basically, if I told you 2x minus 3 equals 1, wouldn't you add 3 to both sides first? So you get 2x equals 4, and then divide by 2. So x is 2. Well, you're going to do the same thing, except at the end you're going to have a square root of x, and then you square it. So I'm going to add 3 to both sides. So 2 root x is equal to 4. I'm going to divide by 2, because it's 2 times root x. So you get root x equals 2. And then what do you do to both sides? You square both sides. So x equals 4. That's the answer. And if I go back and just check the problem out, let's plug that 4 back into there. The square root of 4, so I'm plugging it back into this x right here. The square root of 4 is 2. Okay, 2 times 2 is 4. 4 minus 3 is 1. Okay, so that checks out. Okay, that's pretty mellow. All right, so that's, again, isolating that radical, the variable with the radical. All right, so let's try one that's a little more complicated. What happens if I have something like this? Let's say 2x inside the radical. So 2x plus 3 is equal to 9. All right. So again, we don't do anything with that 2. In fact, whatever's inside the radical stays inside the radical until you square it. So we're going to subtract 3 from both sides. And you get the square root of 2x is equal to 6. All right? And then now the radical is isolated, so I'm going to square both sides. And remember, it doesn't matter what's inside the radical. When you square a radical, it just becomes whatever's inside the radical. Because remember, I did this example, the square root of 105 squared is 105. Okay, so it doesn't matter what's in there, it becomes just that value. So the square root of 2x, all that squared, that's just 2x. And you square the 6 and you get 36, and then you solve for x. So the additional step now is now I got a 2x, and I have another step. I have to actually get rid of the 2 after I've squared both sides. So x equals 18. Okay? So let's do something a little more complicated inside. The square root of 2x minus 3 plus 3 equals 10. Okay, so guys, this is locked, man. You cannot touch that. The only time you can touch that is when the only time you can touch it is after you've isolated that. All right, it's the only time you can touch it. So we're going to subtract 3 from both sides. So you get the square root of 2x minus 3. Still 2x minus 3. I haven't touched it. Equals 7. And then this is isolated now, guys. Right? There's no number outside of it. Isolated means it's just got the radical there. So I square both sides. So 2x minus 3 equals 49. And then I solve for x. So here it's solve for x. So add 3 to both sides. So 2x equals 52. Divided by 2, x equals 26. Okay? That makes sense, everybody? I hope. So again, just to recap everything, make sure that you isolate the radical, and once you do that, then you solve, then you square both sides, and then you solve. Okay? Now, what happens if I get something like this? The square root of x equals negative 4. What is x equal to? Well, you could square both sides, but I want you to understand, even before we square both sides, what can you take the square root of where you get a negative number? Okay? Is there anything you can take the square root of to get a negative number? Right? Because you guys know that I can't have a negative number underneath here. I can't have the square root of negative 16. If I try that in my calculator, I get an error. Okay? Because you can't have, there aren't two numbers that multiply together to give you negative 16 that are the same numbers. Right? Because negative 4 times negative 4 is positive 16. 4 times 4 is positive 16. So there's no negative 16 here. So you can't, and I know you're tempted to do this. Square both sides and you get x equals 16. Okay, but if you go back and check it, your original problem, if I put that 16 back in there, square root of 16 is not negative 4, it's positive 4. So this is the deal. If after isolation of the radical, so after isolation of the radical with the variable inside, if that equals a negative number, then NSB. Okay, no solution, baby. And you guys have to understand that this is where it's no solution because you've got an equals to sign, man. All right? So, again, just if I said the square root of x plus 7 equals 3, first thing I'm going to do is I'm going to subtract 7 from both sides to isolate that x. So square root of x equals negative 4. Oh, negative, warning, danger. Okay, NSB. But that's only after this is isolated. All right? So let me give you another example here. The square root of x minus 3 minus 8 equals negative 2. Okay. Oh, look at that. No, it's no solution. Or is it? Have I isolated this x minus 3 radical? No, I haven't. I need to add 8 to both sides first. And I get square root of x minus 3 equals 6. Okay, it's positive now. That's okay, it's positive. So you square both sides. So x minus 3 equals 36. And then you add 3 to both sides to solve for x. So x equals 39. Okay, and you can go back and check it. 39 minus 3. So if I plug this back into here, 39 minus 3 is 36. Square root of 36 is 6. 6 minus 8 is negative 2. Okay, that's it. That's pretty mellow. All right. Let's try a different kind of problem here. The square root of 6x minus 8 is equal to x. I got variables on both sides. Okay, but it's not a big deal. It's still, one of them has to be isolated. So this is isolated. Okay? It's all by itself with the radical. So let me rewrite this again. 6x minus 8 equals x. What I'm going to do to both sides, I'm going to square both sides. So do you guys agree, again, when you square a radical, it just goes away, and you have 6x minus 8. What happens when you square x? Don't you get x squared? So really, this is what you have. And what do you do when you have a quadratic, an x squared? You have to move it to one side. So I'm going to subtract 6x and add 8 to both sides. So I get x squared minus 6x plus 8 equals 0. And then I factor. Okay, you guys should know that, man. When you see a square term, you got to factor. That is important. Okay, so anyway, it's going to be x minus 4, x minus 2 equals 0. So x equals 4 and 2. There's one issue you have to do now, is I need to check answers. And you do that by plug into original equation. So if I put a 4 in here, 4 times 6 is 24. 24 minus 8 is 16. Square root of 16 is 4. And that's 4. 4 equals 4. Good. I put a 2 in there. 6 times 2 is 12. 12 minus 8 is 4. Square root of 4 is 2. 2 equals 2. That's good. So these are both my answers here. All right? But you have to check, whenever you square something, you have to check for extra solutions. They call that extraneous solutions. Okay, so let's try another one here. But don't forget that. Square root of 3x plus 4 is equal to x. Okay, it's isolated, so I'm going to square both sides. So 3x plus 4 equals x squared. Move that 3x over and the 4. So x squared minus 3x minus 4 equals 0. I factor. X minus 4, x plus 1. So x equals 4 and negative 1. Okay, well, again, this is my original problem. What do you think doesn't work? And I can't hear you because I'm only talking in the mic. But the deal is, can that ever be a negative number? Can you take the square root of a number and have it be negative? No, that's not going to work. In fact, if I plug that negative 1 in there, 3 times negative 1 is negative 3 plus 4 is 1. And then and that's negative 1. Is square root of 1, which is 1, equal to negative 1? No. So that negative 1's out of there. The 4, let's check that out. 3 times 4 is 12. 12 plus 4 is 16. And you put a 4 here. Is 4 equal 4? Sure it is. So this is my only answer, x equals 4. So you have to be careful, math fans. When you plug in, or when you solve for something, you've got to plug it back in to check to see if that answer makes sense. Okay? If it doesn't, then you got to go back to the drawing. Well, you don't have to go back to the drawing board, but if it doesn't make sense, that's not a solution. And if there's no other solution, then the whole thing is no solution. All right? So I got 2 more examples just to practice with you guys on this stuff. So let's do that. square root of negative 6 minus 5x is equal to x. Okay, only going to square both sides. So negative 6 minus 5x equals x squared. Add 6 and add 5x to both sides. So you get x squared plus 5x plus 6 equals 0. If I factor that, I get x plus 2, x plus 3. So x equals negative 2, and x equals negative 3. So let's look at our problem that we have here again. Negative 6 minus 5x equals x. Okay, my question is, both of these are negative. Is there any way that this can be negative when you take the square root of a number? No, it's not. So neither one works. So the answer to this problem is NSB. All right, and again, you can plug it in if you want, but I just know that that won't work because of that negative over there. All right, just because these are negative, that doesn't mean it's always going to be no solution. And I'm not going to do the whole problem like this, but if I had something like x plus 2 equals negative x, and let's say x came out to be a number, x came out to be negative 3. That's actually a good thing, isn't it? Because what happens when you plug a negative 3 in there? Doesn't it become 3? So always just plug it back in to check to see if it works. Okay, your last example is the square root of x squared plus 3 plus x minus 4 equals 0. Okay, so the first thing I'm going to do is I'm going to isolate that squared term, or the square root term. So it's the square root of x squared plus 3 equals negative x. I'm going to subtract x from both sides and add 4. So equals negative x plus 4. Okay, square both sides. And be careful, guys, when you square that, make sure you write it twice. So it's negative x plus 4, negative x plus 4. So you get x squared plus 3, which is what happens when you square a square root. And then if I FOIL that, negative x times negative x is positive x squared. Negative x times 4 is minus 4x. 4 times negative x is negative 4x. And last is plus 16 equals 0. Oops, not equals 0, sorry. It equals x squared plus 3. So let's combine like terms. X squared plus 3 equals x squared minus 8x plus 16. So let's subtract x squared, move that over, and subtract 3. So that cancels, and actually the x squareds cancel. Those 3's cancel there, and I have 0 is equal to negative 8x plus 13. Okay? There's no more quadratic, so I have to solve by moving things over. So I'm going to add 8x to both sides. So you get 8x equals 13 divided by 8. X equals 13 over 8. Okay? And that's it. And if I go back and check it, it's a little more complicated, but you can use your calculator. I'm going to plug it back into the original problem, and it should work. Okay? Well, that's it, math fans. I hope you guys learned something with this about squaring radicals and solving for radicals. All right? Have a nice day, everyone. Goodbye.